All right. Need to take a look specifically at division with exponents. I think one day we covered briefly kind of the general rules for a lot of these properties, a lot of these situations. Today's going to be the division. Again, with division with exponents, you've got to have like bases, and that's primarily what you're going to see today, so it should be fairly straightforward, okay? A few examples here. First one, pretty easy. Got x to the 8th divided by x to the 3rd, okay? We have like bases in the x's, top and bottom, so we will be allowed to apply the rule here. Does anybody remember what we do with exponents when we're dividing with like bases? The opposite. Subtract. Get to subtract the exponents, okay? Now, here's the one thing that I would suggest that you ask yourself when you start these is right here, where is your largest exponent? Top or bottom? Top. It's on the top, okay? So what we're going to do is we're going to hold the x's up top because we want to try to be in a situation where we are subtracting large exponent minus smaller exponent, okay? So we're going to hold the x's up top, and we should be able to take the 8 minus the 3, which would be 5. So right there, x to the 8th divided by x to the 3rd should render x to the 5th. Wherever that largest exponent is, that's where I'm going to keep that base, and then we will subtract exponents. Okay? Now, technically, they're on the bottom. Technically, there's a 1 there. You don't have to show that. A 1 in the denominator is always understood. So just x to the 5th would suffice. If you put it over 1, that's fine. All right, take a look at the next one. X to the negative 2nd divided by x to the 5th. Where's your largest x at? This time it's on the bottom, so here's what we're going to do. We're going to hold the x's on the bottom, okay? That's where your largest x is. That's where your largest exponent is, so hold it there on the bottom. Now, be careful here, okay? That exponent up there on the top is negative. So when you subtract these, you need to be real careful here. So here on the bottom, we should have 5 minus negative 2. 5 minus negative 2. Because again, the rule states that we're going to be able to subtract the exponent, so subtraction is involved, and we're subtracting off a negative number. So need to be real careful here. 5 minus the negative 2. Now, because we're pulling everything to the bottom, there's nothing left on the top. What must you show on the top if there's nothing there? Must show a what? A 1. Put a 1 up there. You have to show the 1 up top. What is 5 minus negative 2? Is what? Well, minus a negative becomes a positive, so really that becomes 5 plus 2, which is positive 7. And again, hopefully, if we are truly subtracting the large exponent minus the smaller exponent, we should end up with a positive result. So there it is. Final answer, simplified, 1 over x to the 7th. Now, let me show you one alternative. I'm going to do it right over here in red, okay? This would be an option for you if you want to take the option, okay? Do you remember those 5 words? What were those 5 words that we learned in order to get rid of a negative exponent? First word was move. Move it to lose it. Move it to lose it. Okay? So, I will offer this as an option. You don't have to do this, just giving you options here. We recognize the problem has a negative exponent in it, the x to the negative second power. If you wanted to, you could take x to the negative second and you could move it to lose it. We could move it to the bottom. And we could move it to the bottom of this. And down there on the bottom now you would have x to the fifth and x to now the second power, the positive second power. So if you wanted to, we could eliminate the negative exponent in the beginning. We could move it to lose it. Here's what we would be looking at. 1 over x to the fifth times x to the second. When we multiply with like bases, you're allowed to add the exponents. So 5 plus the 2 is 7. And notice, I mean, that's the same answer that we got when we originally did the problem. Okay? So if you are somebody that these negative exponents really give you a lot of trouble, and you're like, look, you know, me trying to subtract these negative exponents, I make a lot of silly mistakes with that, this would be an option. You could say, look, from the beginning, I'm going to try to get rid of the negative exponents and try to just deal with positive exponents. But that is completely up to you and your preference, okay? And that's what you're going to find with a lot of these exponent problems is there's a lot of different ways to get to the right answer. Just depends on kind of how you see it and what you're going to be comfortable with, okay? Any questions here with these two examples? Options. Options are good. Okay. All right, next example. There you go. Jot that down real quick. X to the fifth y squared divided by x cubed y to the ninth. So just a little bit more going on here. Not a lot. We still have division. We still have like bases top and bottom. Where's the largest x? Top or bottom? X to the fifth, x to the third. Top. Keep your x's up top. X is going to stay up top. And if I subtract those exponents, 5 minus 3 is what? 2. So we should have x squared up top. Where's your largest y? Bottom. Hold your y's on the bottom. 9 minus 2? 7. Y to the 7th. And that's it. Took care of our x's, took care of our y's. We have positive exponents in the end, and that's what we like. Can't leave negative exponents in our answer. Pretty straightforward there. Any questions there? We okay with that? Just a little bit more to look at. All right, let's go here. 4 to the fifth divided by 4 to the negative second power, okay? The base doesn't always have to be a letter. Doesn't always have to be a variable, okay? The base could be just a number, as we're seeing here. The common base, top and bottom, is 4. So we've got 4 to the fifth power divided by 4 to the negative second. 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 4 to the nega So we have like bases. We're going to be able to apply the rule. Where is your largest 4? Top or bottom? Where's your largest 4 at? Top or bottom? Top. Largest 4's up top. Going to hold the 4's up top. That is our common base of 4. And again, we're back in a similar scenario here. We're going to have 5 minus negative 2. 5 minus negative 2. And minus a negative becomes a plus, so really this just becomes 4 to the 7th power. You can put the 1 on the bottom, or you could be without it. 1 on the bottom is always understood. So 4 to the 7th power, final answer. Now, if they want to know what 4 to the 7th power is, we could always go to a calculator and expand that out. That's going to be a pretty large number, but at this time, if we can get that far, I think we're good. And again, options, if you wanted to, you could have taken 4 to the negative 2nd power. You could have moved it to lose it. You could have moved it up top to eliminate that negative exponent. And you could have had 4 squared times 4 to the 5th, which would have allowed you to add the exponents. And of course, 2 plus 5 is still going to be 7. We know we're going to get the same answer, but again, you've got that option if you need it. If you want to eliminate negative exponents from the beginning, you can, and then go from there. So there's exponent rules for everything. Any questions here? So far, so good? Okay. All right, let's take a look at this one. Now, a little bit more going on here visually. You've got 3 different variables, 3 different bases. You've got some positive exponents. We've got negative exponents. So a little bit more visually going on here to kind of distract. Now, first time through, we're going to work this as is. Then I'm going to come back, we're going to work it, and we're going to remove the negative exponents. So we'll work this a couple different ways so you can see that. Now, be careful right here. Be careful with your negative numbers. Take a look at your base of x. Which number is larger, negative 2 or negative 3?
Negative 3.
Which one's closer to 0 on the number line? Negative 2. Okay, so if you're kind of looking at it, kind of approaching it this way, and you're seeing both those negative numbers, and you're trying to decide where's my largest x, be careful with those negative numbers. The closer you are to 0 on that negative side of the number line, you're larger. So really, the x's should stay on the bottom. Your largest x, negative 2, is larger than negative 3. Now watch this. You're going to have negative 2 minus negative 3 down there. So be careful. Be very careful with these negative exponents. X's are going to stay on the bottom. You're going to end up with negative 2 minus negative 3. We'll come back to that here in just a second. Where's your largest y? Top. And that's going to be, they're both positive, so that makes that pretty easy. Up top, you're going to have 6 minus 3. Where's your largest z? Largest z is on the bottom, so z's will stay down on the bottom. And you're going to have 5 minus negative 1. 5 minus negative 1. Now up top, what's 6 minus 3? 3. Up top, y to the third. Easy. Now on the bottom, negative 2 minus negative 3. Minus a negative becomes a plus, so right there you really have negative 2 plus 3. Or 3 minus 2, however you want to say it. What's 3 minus 2? 1. You're going to have x to the first power down there. You can write the 1 or you can leave it off. An understood 1 is okay for an exponent. You don't have to show it, but if you do, that's fine. And then with your z's, 5 minus negative 1 is really 5 plus 1, which is? Five plus 1? Thank you. There it is. Final answer. Y to the third over x z to the sixth. Okay? Now, if I go back and I eliminate these negative exponents from the beginning, take a look here. If you wanted to do this. This problem could be a good candidate for that for some people because it looks like there's a lot going on visually. You see a lot of different, you see some different bases. We see a lot of negative exponents. So this one could be one where you as an individual might say, you know what, let me get rid of those negative exponents and just let me deal with positive exponents. Would this x need to move? Does it have a negative exponent? Mm-hmm. Yep. What about this one? Mm-hmm. Yep. This one? Mm-hmm. This one? Mm-hmm. That one? Mm-hmm. Yep. Mm-hmm. Nope. Okay. So what we could do is we could move these three. Move that one up. Move that one down. Both the y's stay. Z to the fifth stays, but z to the first moves down. So if you wanted to, again, this is nothing you have to do, you could say, look, I'm going to eliminate the negative exponents from the beginning. Anything with a negative exponent, I'm going to move it to lose it. That's what you're seeing here. Everything now has a positive exponent, which may be more visually appealing for you. You might look at that and go, okay, I can deal with this better. Now it might be more obvious. Where's your largest x at? Top or bottom? X squared, x to the third. They're both positive. Which one's larger, a positive 3 or a positive 2? We're on the positive side now. So 3 is larger than 2. Bless you. Hold your x's on the bottom. 3 minus 2 is 1. Your largest y is still on top. The y's, it was no different. Y's are still up top. 6 minus 3 is 3. And now for your z's, both z's are on the bottom, so you're multiplying them. Z to the fifth times z to the first. We keep the base, we add the exponents. 5 plus 1 is 6. Obviously, we're going to get the same answer. We just arrive at it a little bit differently. But you've got to decide for you what's going to be easiest and what works best for you. Okay? If you are somebody when it comes to subtraction with these negative exponents, and there tends to be a lot of mistakes made, it might be worth your time to look at removing those negative exponents from the beginning and then dealing with the problem from there. Completely up to you though. But that is the gist of today's lesson, is just trying to get comfortable working with a division setup with like bases and exponents, whether they be positive or negative. Okay. Here's what we're going to do. I'm going to choose these for you. 1, 3, 5, 9, 10, 11, 14, 16, 17. Most of these should be pretty straightforward, and there we go. Those should pertain to the examples that we did. So 1, 3, 5, 9, 10, 11, 14, 16, 17, 22, 23, 25, 27, 29, 31, 32. Several of those are going to be just kind of one-steppers. You're going to do it, be done, like number 1. Number 1 should be pretty easy. Number 17 should be pretty easy. Number 23, pretty easy. Number 29, pretty easy. Okay, don't even have any negative exponents there. So a lot of those are going to be pretty quick. Okay?